is Rachel Shmulva.
I'm Danny Alexis. I'm Alan Bailey. You like Ted?
And today we are speaking about the company and case overview. IBM predicts cloud computing demand for sports tournaments. To start off our presentation, Alan Bailey will be talking about keywords and definitions and some general basic company overview and case overview.
Okay, so I will be discussing the keywords and definitions. All of these keywords and definitions are integral to the presentation. They are the building blocks and the structure of the PCC, which is predictive cloud computing. So predictive modeling uses statistics to predict outcomes. These outcomes could be any time in the future or far from it, but let's just say they're for the future. Forecasting is the process of making predictions to maximize efficiency. We covered a lot of this in class with forecasting models, but the predictive cloud computing made sure to maximize their forecasting models. Cloud computing is shared pools of configurable computer system resources. We'll get more into that later. Big data, so this is the data that we're referring to. It is important to know that this data is more complex and isn't as broken down that it can be used in a regular computing device. So big data requires special software to process. Sports. So sports is very important for PCC, the predictive cloud computing. In the early stages of the software, IBM chose sports as their guinea pig, basically. I mean, for sports such as tennis, golf, everybody loves tennis. Wimbledon is a good example of Australian Open. Many of these sports tournaments have apps for their users, apps to view the live games, scores, standings, and even stream content. And as you know, streaming content requires a lot of resources. It's expensive for companies to provide all of that information. So what the PCC did was the PCC provided forecasting models to predict how much resources to allocate to the apps. Social analytics, one of the definitions, is the gathering of data using social behaviors. So based on social media, Facebook, Twitter, PCC was able to gather the data and determine when it would make more sense to provide the bandwidth needed to run these apps. Too much software provided and it's a waste. Too little and the apps break down and the users aren't happy. So all of these definitions contribute to the overall PCC's general running. So I'm going to give the company and case overview. So IBM is a leading company in analytics, mobile, and cloud technologies. IBM's Global Technology Services, or GTS, created a software called the PCC, basically the predictive cloud computing software. And it takes external factors and historical data to come up with an efficient forecasting model for apps, such as Wimbledon, US Open scores. It actually could be used for many things, but in its early stages, IBM released their software to sporting companies, which I'll explain now. Take for example Wimbledon or the US Open. They provide apps. All these apps have scores, streaming content, player history. It takes a lot of energy to run these. So for these companies, it is extremely important to be able to know how much technology, software, resources to put into their apps. So taking into account social media, scores, history, and exactly how interesting the games are, they have to know when they should put the right amount of technology and resources into their apps. And that is the history of the PCC. As all right, stop there, and then let me just stop the video.
It's in the same position.
I'll stay in the same position.
Just go. We'll cut it out. Go.
Okay. As my other, what's the word?
Colleague?
No. As my other colleagues will show, this can be used in a much more complex way, not only sports. But as a sports user, I know that many times in 4 or 5 years ago, I was streaming content and watching John Isner versus Nicholas Mahut, and all of a sudden the app crashed. I was like, this is ridiculous. And I guess IBM was able to solve this with the release of it a few years ago. Thank you.
So the first of the 3 issues that IBM has is the manual effort needed. So by this I mean the manual effort that is needed for client requirements in the time period between planned requirements and unplanned demand for the delivery service. For example, it is very hard for IBM to analyze, coordinate, and carry out their computing resources. This is because the requirements are difficult to complete because tournaments and other such large organizations have changing business requirements and demand traffic, so there's an increased pressure for IBM to deliver these services on a timely basis, or else they are extremely susceptible and able to anger such large clients and hurt their own business. The second problem that IBM faces is the effect of susceptible computing adjustments that affects how the on-site teams work on supporting the tournaments. For example, some of the worker shifts may last up to 16 hours in order to implement, deliver, and support the cloud computing platform that allows both fans and the tournaments to carry out some of the important information and data that fans enjoy to look at while these tournaments go on. The last and final problem that IBM faces is the need for a new forecasting system. This is the largest problem because it impacts mostly how IBM delivers their programs to their fans. So if something like this messes up, IBM is in big trouble with some of its big clients. So the need for this forecasting system is because the current forecasting system cannot predict anomalous sporting events. So that means that they cannot predict when there's going to be an increase in demand on sites and the site could potentially crash because there are so many users, let's say, looking up new scores when they found out there's a new tiebreaker between 2 players. So they need a new system that is able to predict these type of events and predict demand that is going to change so that they can be able to prepare for these types of situations. It is absolutely critical to deal with some of these problems because without doing so, IBM is unable to satisfy both clients and fans' services, requirements, and demands on a timely basis. So it is very important to deal with manual effort, computing adjustment, and forecasting issues because without doing so, IBM is unable to satisfy mainly its clients' requirements and unable to deliver the services they are supposed to be delivering. So all of these issues have become especially important in today's day and age because technology is changing and it is vital for IBM to keep up with these adaptations. An example of how critical some of these problems are was that in 2008 in the US golf tournament, Tiger Woods and Rocco Mediate were suddenly scheduled to play at a championship game on a Monday. And in order for fans to keep up with this change of game time and to keep up with the game, they had to be able to access the game on digital media channels on a Monday afternoon instead of on a Sunday. And this is because most people don't have access to TVs in work. So IBM had to be able to deal with such a problem as this by having the manual effort, being able to deal with the computing adjustments, and being able to predict some of the demand changes. Without doing so, there could have been a crash on their site, which would have devastated both fans and the golf client.
With the solutions to the major issues covered, IBM must now implement each solution to correctly solve the problem. First off, the IBM team needs to work with a resource planner to identify additional resources, place the resources in the production field, create the operational system, build the middleware layer, configure application and security settings, and test and deploy the system. This process should be repeated minimum 6 times to reduce impact on team members and as protection against unforeseen demand. Over allocating computing resources in excess of 50 to 60% of expected demand is a common practice and something that must and should be done. The on-site team focuses on the day-to-day operations of the platform and determines anomalies that could potentially shock them. If allocating additional computing or labor resources is necessary, the on-site team must coordinate with its remote support team and GBS to expand the resources, thus making the execution complex and time-consuming and distracting on-site support from focusing on real-time tournament events. The next step is to implement and develop PCC, which is a combination of advanced analytics and techniques in an environment in which diverse data arrives at various velocities. Its novel and advanced analytical aspects include social, sporting, and cloud-based predictive modeling, long, medium, and even short-term cycling forecasting, as well as sliding parabolic windowing of time-varying cyclic forecasting and event-based prediction storage. Thank you.
So streaming data kicks us all off. It sends its information to the preprocessors, which use the streaming data bit by minute to impute any missing values and therefore create a seasonality curve. It then sends its information to the time series ensemble, which uses 5 different forecasters to basically predict future server demand. It then goes to the post processors, which are basically smoothing out the curve. They filter out any numerical errors, delete duplicate values, and remove anomalous forecasts. It then sends all the information to the distributed chain simulation, where it combines with the published sporting data and eventually the high volume data at rest to create random simulators of golf and tennis tournaments, and it goes back and forth with the feature extractors until it gathers enough information to where it can send it over and advance to the predictive modeling stage. The predictive modeling stage basically detects large spikes of demand to create an even stronger event forecast. The residual forecaster is actually like a post-processor, which was used before, and it basically smoothens out the forecast by using a couple of different systems called the Powell optimization, Loess interpolation, and Loess extrapolation. It then goes to the merged cohort, where basically the cyclical forecast and event forecast are combined by a sliding parabolic weight adjuster. Finally, it goes into the cloud and it's put into action. It adjusts the number of web servers of the cloud to match the resources of the predicted demand. All right, next. And here's a video that further explains why predictive cloud computing is so.
IBM uses Power Systems technology to deliver Australian Open, the Masters, Roland Garros, Wimbledon, US Open Golf, US Open Tennis, and the Tony Awards. IBM's private cloud is involved in the end-to-end delivery of these various sporting events. Every single score, stat, or web page is delivered from IBM's private cloud. We use Power Systems as well to help us analyze our systems and optimize our cloud. We're doing this work behind the scenes to look at social media and look at our historical web logs and optimize the infrastructure to have the right number of resources available at the right times. Predictive cloud and the analytics technologies IBM provides lets you forecast what you're going to need later in the day, and then the IBM cloud technologies let you match your resources to that demand. IBM technology, whether it's analytics or cloud or predictive cloud that we use to deliver these events, can be applied to a variety of businesses, whether it's a retail industry with a website or a Fortune 500 company that has a mobile application. IBM Analytics provides businesses with specific things they can do to enhance sales or increase customer retention at a very granular level that you can't find with other technologies. For example, retail can have a lot of trouble in meeting web demand if there's unexpected spikes or even social media discussion about their product. Predictive technology can look across social media and look across their historical usage and detect ahead of time that there's more interest in your product than you thought, and then you need to ramp up either shipping or additional cloud resources on the back end. The IBM Analytics technologies that we use enable businesses to move from being reactive to more proactive. This helps them reduce their operating costs and make better decisions. Power Technology is great for providing highly reliable cloud services. We use various aspects of Power Technology during these events. By combining emerging technologies such as cloud, big data analytics, and social media together into a predictive system, we're really on the cusp of a new realm in computing, in being able to accurately forecast what's going to happen in the future. Power Analytics on cloud is very exciting and enables businesses to be more confident in their decisions and do things they couldn't do previously, such as look at huge amounts of data and data in real time and use that to adjust their business and business decisions moving forward.
So why were the PCC so important? In the end, it actually saved 51% of computing hours, which means 134 hours each day of every event. That's 80 days, and therefore goes to 446.7 computing days. That's a lot of work. It actually also contributed to IBM's intellectual property by filing 16 utility patents that have been filed with a couple of different areas like advanced analytics, cloud computing, and machine learning.
Imagine, like Rod Laver, you're watching the 2009 Australian Open final between Roger Federer and Rafael Nadal. 2 all in sets, they're cruising along, match point, the game turns off. You're sitting at your desk, you're like, oh, it turned off, oh, and you're going crazy. Now, imagine a scenario, you're the CEO of IBM, you've allocated money, you've allocated $1 billion in resources, and you note that only $200,000 were used. Look at the discrepancy, you're probably going crazy. Imagine a world without those discrepancies amongst the allocated resources and the provided resources. The PCC. There you go.
We wanted to thank you for listening and watching our presentation. We just wanted to add a couple of things about our thoughts on the PCC system and overall IBM's new technology in general. First off, we think the PCC system is genius and extremely innovative and is going to change the way IBM predicts data forever. But one thing we think that IBM should look out for and pay keen attention to is maintenance of the system, because if a system as large as this crashes, everything that IBM is responsible crashes as well. So that's extremely important. But otherwise, thank you for listening and watching.
Thank you for listening.
Bye.
Have a good one.